Hi guys, how are you? How you doing? Today we're back again to you and we'll explain the mathematical induction. We're gonna do some problems and some solutions about my mathematical induction and part 4. Again, if you have any question, all what you have to do is just text me at this phone number or send an email and tell me what topic you need help with. I will be more than happy to help you. Now, I need you to be good and to be safe. And don't forget, if you like it, subscribe. If you like it, subscribe. Today our class is very important class. It's about some proof. I'm gonna do my best to make it as easy as I can. I believe everything is hard till the kids understand it, the student understand it, anywhere, in any level, till they understand it. Let me start my class. Actually, to save your time, I start something. Okay. Our class is mathematical induction. Mathematical what? Induction. Mathematical induction. Now, I think this better. Okay. It's mathematical what? Induction, which is a type of proof in math. The first thing I'm going to ask you, what is, let me just hide this. Who can tell me what is the sum of the first seven odd numbers? What is the sum of the first 7 odd numbers? 7 odd numbers, which is, he wants you to add 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. Okay, good. Good. 7 odd numbers. What these odd numbers? 1, right? Let me just erase these two. Okay. This is the black one. If you add them, we'll get 49. Wow. Okay. Then look at, just follow me. Follow me. What is the sum of the first 7 odd numbers? What is the sum of the first 7 odd numbers? The sum is 49. Okay. What is the sum of the first 8 odd numbers? 64. How I get 64? You're gonna find the rule, not me. What the sum of the first 9 odd numbers? 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus what? 17. 9, 81. What's the rule, guys? What's the rule? The rule is you take this number and you square it. How many numbers, how many odd numbers you square? And we tried it here. Here for you. 1 plus 3 plus 5 is 9, 7 plus 9, 16. This 11 and 13, 24. If you add this, 49. Now, depend on this, the sum of n odd numbers is what? N squared. Now, the standard form, SF stands for the standard form. SF stands for standard form for any odd number 2n plus 1. This, remember this, you're going to use it a lot in your life. 2n plus 1. When, how this you can get the odd number? One of the students, you asked me, how I can get the odd number from this? Just put n equal 1. Start with n equal 1. When n equal 1, 2 times 1 is 2. Minus 1 is 1. When n equal 2, when n equal 2 here, when n equal 2, 2 times 2 is 4, minus 1 is 3. When n equal 3, 2 times 3 is 6, then whatever you plug in here, you get odd numbers. Then, the rule, let us sum, do we need this? No. Okay, I'm gonna leave it, I don't care. I'll leave it here. I'm gonna write my rule here. I'm gonna write my rule nice and neat. Here. And I will prove it. Okay. I'm gonna write it, then I'm gonna prove it for you guys. Now, look here. 1 plus 3 plus 5 plus 7 plus tack, 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 plus 2n minus 1, the last term, which is all odd numbers, equal n square. Any odd numbers, all what you have to do, guys, all what you have to do is to know how many odd numbers you have, then you square that thing. 7 odd numbers, 49. 9 odd numbers, 81. That you can play this with you. Now we're gonna prove this using what? Mathematical induction. Prove, use mathematical induction. We're gonna improve it. Okay. How many steps we need for the mathematical induction? 3 steps. 3 steps to prove. Always remember how many steps we have? 3 steps. Step 1. Statement true for n equal 1. What is the meaning of statement true for n equal 1? You plug 1 in the left side and you plug 1 in the right side, and you see if that's true. In the right side, 2 times 1, 2, minus 1 is 1. This is left side. Let me just make left side in what? And different color. Left side. Right side, you just plug n square, 1 square is 1. Then the first statement is true. Step 2. Step 2. Statement true for n equal k. We have left side and we have right side. Okay. Left side, 1, 3, 5. Right? Plus 2k minus 1. Instead of n, we plug k. Okay. Right side, k squared, which is the same as we have, which is the same n squared. The last step, which is the step needs proof, step 3. When the term is statement true for k plus 1. What this mean? That mean when we have one term after k, when we have a term after k, this term for sk plus 1. I'm going to make it for s, for the term it has to be sk plus 1 as I explained. What this means, sk plus 1, if this true for 1 plus 3 is true, look here, to understand what I mean by this guy here. For sk plus 1. Okay. Now, just let me explain something for you guys. What I mean by, to make it clear. sk plus 1, as example, if this is good for the 1 and 3, which is equal 4, it's good also for 1 and 3 and 5. Good? It's good for 1, 3 and 5. Good. If this is good for 1, 3 and 5, it's good for 1, 3 plus 5 and 7. If this is good for 1 plus 3 plus 5 plus 7 plus 9, it's also good for 1 plus 3 plus 5 plus 7 plus 9 plus 11. And you have to keep going, keep going, keep going. Then let me just show you what I mean. That means the term, look here, 1 plus, you add 1 plus 2, 3, right? For the odd number. Then 2, 5. Then up to 2k minus 1. Now, what's the term after this? You add 2, or you can put it like this. 2, change k to k plus 1. Which is going to be, if you add 2, it's going to be 2k plus 1. And you have two choices. 2, you add, right? The term after that is what? 2k. If you add 2, because you're adding 2 to 2k plus 1. Then the new term added here is 2k. This means the term after the last term. Let me just put it in different color. Green. K plus 1. 2k. Why? Because look here. 1 plus 2, 3. 3 plus 2 is 5. 2k minus 1 plus 2, because the difference between any two terms is 2. Good? Then we add in k plus 1 in this side. In the other, this left one, this is my left side. Let us go to my right one. My right side. What I have on my right side, I have in a square. What I'm adding now, I'm adding what? 2 what? K, I'm adding k plus what? 1, right? I'm sorry, k square. Small eraser. K what? Square. Now I'm adding what? K plus 1. I'm adding what? This becomes k. The old one, k squared, now becomes k. The sum, this k squared, becomes k plus 1 squared. Let me just illustrate it and make it super easy. Now, in this side, now we need to be true for sk plus 1. We know the sum is n, the sum is what? N squared. All what you have to do to change k and the sum for the sum is k plus 1 squared. This for the right side. For the right side, the sum, okay, we'll see it here, is k n squared, which is k squared. N or k, the same. Now, yeah, the sum from here to here, the sum from here to here, how much, guys? This guy from here to here is what? K squared. Right? Let us back here. Remember, k, n, whatever you want, it's up to you. Okay. Okay. You see that? For up to 2n minus 1 is n squared. If you change n to k, it's going to be k. If you change n to m, in some books they're going to use m. Some books they're going to use m. Some books they're going to use what? K. Whatever they want to use, any letter. Now, what we did, the first step, we prove it for n1, for left side and right side. Left side, which is 1, only we have. Or you can plug here, 2 times 1 is 2, minus 1 is 1. Right side, 1 squared is 1, good. For nk, you change n to the k. We have 1 plus 3, 5, right? K squared. This is the left side and the right side. Step 3, for statement true for sk plus 1. For this side, k to k plus 1 becomes k plus 1 squared. For the left side, you add one term, the term after. You have to have the sum for all the term plus another term, which is how I get this term. I noticed that the difference between any two consecutive terms is 2. Then you add 2 here, 2k minus 1 plus 2. This you got it plus 1. Yeah? This one from me. I'm gonna explain on the side. And I'm gonna add 2 here. I don't know if you don't understand. In case, I assume there's one of the student needs me to explain it. Then 2k minus 1 plus 2. When you add plus 2 becomes 2k plus 1, which is this term, this one here. Okay. Let us finish the problem. Then this k squared, and this is this guy, 2k plus 1, right? 2k plus what? 1. And this side, here in blue, k plus 1 squared. What k plus 1 squared? K plus 1 and k what? Plus 1. Foil it. K squared, k plus 1. K squared plus 2k plus 1. Wow, which is truth statement. Good. Next problem. Okay. Problem. I'm going to start the problem with the funny and simple. I'm going to take this video. Okay, I'm going to finish this problem. Problem, sum of even numbers. Okay, 1. 2 plus 4 is 6. 2 plus 4 plus 6 is 12. 2 plus 4 plus 6 plus 8 is 20. Can I find the rule for this? How many terms I have here? I have here, look here, I have n equal 2. How I know 2? 1, 2 terms. And n equal here how much? 3. Okay, and n here equal 4. Okay, I promise, I will back again and explain arithmetic and geometric sequences and the sum of the arithmetic and geometric sequences to make this topic simple and easy for you guys. Now, look here, if n 2 and the sum is what? 6. The sum here is how much? 12. The sum is 20. What do you notice? If you multiply 2 times 3, 3 times 4, 4 times 5 equals 6, that means n and n plus 1. Then the sum, I can find the rule, the sum of even numbers. This is, can I erase it and make it nicer? Thank you. The sum of even numbers n plus 1. The sum. Imagine how it's easy. Okay, what is the sum? Look at what is the sum of the first 8 even numbers. What is the sum of the first 8 even numbers? Applying the rule, 8 times 8 plus 1, 8 times 9, 72. Right away. If you want to add them, 2, 4, 6, 8, 10, I will not do that again. Right? just to show you that we are right. 4 and 6, 10. 2 and 8 is 20. And here what? 30, 22, right? 30 what? What I did? 2, 4, 6, 8. 6 and 6, 10, 20, 22. How many numbers do we have? We need one. Okay, I know we need the last one. The first 8 numbers. 8 times 9, 72. This 7 numbers. We need one more. Now I know that. 22, 30, 22, 36. Left for us one number, which is 16. Which is 16. 20 plus 36, 56 plus 16 is 8, 72. If you add 20 plus 36 plus 16, which is 72. The same. We have 8 numbers. Okay. The 8 even numbers. Here 4, here 3, and that the 8. Let us improve it. Now, standard form for even numbers is 2n. Then now you know the standard form for odd number, which is, you know the standard form for odd number 2n minus 1. The standard form for even number is what? 2n. Now apply the rule. 2, 4, 6, 2n equal n squared. I'm sorry, n plus 1. n plus 1. n plus 1. Prove. Now let us prove it. Prove, right? Use mathematical induction, MI. Step 1. Step 1 for n1. When n equal 1, plug n1 from left side, and here what? Right side. Left side we have 2. Right side we have 2, right? The first even number, n, right? N is 1. 1 is n equal 1. Right side n equal what? 1, right? Small 1. 1 plus 1, which is 2. Good. That means true. 2, P of k, I mean S of k, S of k is true. S of k is true. True, which is true. If you change n to k. If you change n to what? 2, 4, 6, 2k, k plus 1. Okay. Last step, right? Last step, which is the one we want to prove, 3. It's good for sk plus 1. It's good, the sum is good for what? The sum is good for sk plus 1, which is one term more. Left side, we have, on the left side what we have, remember guys, 2 plus 4 plus 6 plus 8 up to the 2n. What's the term after the 2n? We have to add 2. We have to add what? We have to add plus 2n plus 2, right? Because the difference between each two terms is 2, right? The difference between each two terms is, this is plus 8 here. Plus 8. The difference is 2, 2, 2, 2, 2, 2. This for the right side. For the right side, For the right side, I will, for the right side, the sum will be, the sum will be, for the, look here, now we're gonna change k to k plus 1. K to k plus 1, each k. Now, look guys, I'm gonna leave that, okay. I'm gonna use this color, k plus 1, for k, and the green, I'm gonna leave the green. I'm gonna leave the green. Plus 1, and the red k plus 1. Good. Let us see if that's equal to this, both sides. The blue guy, the blue here. Here, the blue guys, you know, all of you, you know the blue, we done this, n plus what? 1 plus 2n plus 2. And this for the left side. For the right side is k plus 1, k plus 2. Become. Okay. Okay, let us see if this is the same. Look, watch. If this is the same, watch. n plus 1. And here, we're going to take this guy. What we're going to do, take 2 as a common factor, plus here. And here what? n plus 1. You follow me? Oh, we have to change this to k. Because we talk about k, right? We remove the k. This is gonna be, that's good, yeah. Only change n to a k. And you good. K. And small eraser, this k, everything is gonna be k. Just k, yeah. Change what? Change n to k, k plus 1, k plus 1, 2, k plus 1. Now we have k plus 1 as a common factor. You see, GCF, factor by grouping. K plus 1 and k plus 2. And this is, wow, the same, right? Then this statement true. This we took long time. Have a nice day, guys. I wish you are good and be good, be safe with your family. I wish for you the best. If you have any questions about mathematical induction and you need me to prove it, all what you have too many problems. Just please send me that question, send it to me via email or a text message. I'll take a picture and send you as a text message. Any problem you want. Thank you and have a nice day.